because I haven't put those back yet. All right. Okay. So, ladies and gentlemen, tomorrow is your test. Your test is 6 problems. Okay? Now, if you look at the formulas on the top of worksheet packet 2, there are 7 different formulas up there. So chances are you are going to be using each one of those formulas. Now, you will also need to find the density of gases, either at STP or at non-STP. So if you cannot remember the formula for density, you may want to write it on the top of your yellow sheet. Density is equal to mass divided by volume. Okay? So that you have it. Here, ladies and gentlemen, are 5 practice problems that you could take. You can go to the lab stations. You can work on them there. You could take them to a desk. You could work with a partner. And you could work on solving these, ladies and gentlemen. And I also have answer keys for them so that when you are done solving them, you could look at the answer key and see if what you did was correct or incorrect, see if you made any mistakes or not. So that's something that you could also do today, ladies and gentlemen. And again, if you want to work on them with scratch paper at your desk, if you want to go back to the labs and grab the chalk markers and work on them there, you are welcome to, but there are a bunch of them over here. One thing we do need to do is we do need to finish up the lab from yesterday. Now, this will not take us long because we do not have a lot to go over. We gave you we were on problem number 3, PV equals nRT. Pressure is what you calculated in number 2. So the pressure that you got in question 2, please remember, the pressure of the gas inside the collecting tube came from the hydrogen gas that was released from the experiment and from water vapor that the gas bubbled through. So we learned, and I hope you're listening because I'm answering questions for you at the end right now. We learned that the pressure of the water inside your container was based off of the temperature of the water. That is what determined which value you used. And how did we find that value, ladies and gentlemen? We went to a reference manual. I took a page out of our CRC handbook. You could have Googled it. You could have looked it up. You could have used some reference source because it is a known value. But in problem number 2, ladies and gentlemen, we said, okay, this total pressure, which was equal to the pressure in the room. Why was it equal to the pressure in the room? What did you do in the lab that made the pressure in the room and the pressure in your tube equal? That was the part where you used the tall graduated cylinder. Do you remember how we took it, we put it into the graduated cylinder? And then we moved it up and down until what happened to the water levels? They were equal. The reason we did that is when the water levels were equal, the pressure of the gas inside the tube and the pressure of the gas outside pushing down on the column of water in the graduated cylinder, those two pressures were equal. So that was the way we were able to actually measure the pressure inside the tube without having to put some sort of instrument in there. Okay? So what we call equalize the pressures, when the water level inside that thin gas collecting column was equal to the water level in the graduated cylinder, the pressures were equal as well. Okay? So that was when this total here was the pressure of the room, because when we had those water levels equal, the pressure inside that tube and room air pressure were the same. Now we subtract the pressure of the water vapor, which we got by looking at the temperature of the water and the reference sheet at the end of the lab. We can then find the pressure of the hydrogen gas. Questions? Okay, so in this PV equals nRT, this pressure that we got right here goes in here. The volume is the volume of the gas that you collected, but we need to put it into what unit? Liters. Please remember, 1,000 milliliters equals 1 liter. So if you have X milliliters, you are going to do this to get it into liters. Now, in liters, this is going to be a very small number, like 0.00 something, okay, or 0.0 something. N is what we're solving for. What is the R value for kPa? So that's what we're going to use there. And what is the only thing that we need to do to temperature, ladies and gentlemen? Turn it to Kelvin. So temp in degrees Celsius plus 273 is going to equal your temp in Kelvin. You have everything you need to solve for N. Questions? Okay. After you do this calculation once, you're going to do it again. Now, maybe your pressure changed. Maybe your volume changed. Maybe your temperature changed. Maybe they didn't. Maybe they're very close. But if they did, plug in that new number, solve again, and give me the answer for trial 2. Even if it's the same answer, give me an answer for trial 2 for all of these. Questions? Why are you shaking your head no? Okay, good. You had me worried there for a minute, sir. Okay? Now, the last thing that you're going to do is you are going to do what is called a percent error calculation. You are going to take your answer from calculation number 3 and subtract your answer from calculation 1. These are both moles. Okay? These are both moles. And then you are going to divide it by the calculation answer in number 1. You take that times 100. Now, when you do the math for this, it is very important that Calc 1 minus Calc 3 need to be put in parentheses, ladies and gentlemen. The number that you get from calculation 3 minus the number that you get from calculation 1 need to be put in parentheses. When they are then put in parentheses, you then hit divided by the same number from Calc 1. Ideally, you're going to get a very low number here. Could be a negative number, but you're going to get a very low number, like under 5%. Because the times 100 means we're going to get an answer as a percentage. Do it for both of your trials. Questions? Okay, now if you were paying attention a few minutes ago, we answered these questions for you. Why is it necessary to equalize the water level inside and outside the gas collecting tube? When we put it into the graduated cylinder, we got the 2 water levels equal. We just told you why we did that. Number 2. What was the total pressure of the gas collected in the tube? Do not give me a number, give me an explanation. So what gases were in that tube when you were done? It was more than just the hydrogen gas. There was another gas in there. Tell me what the gases were. By the way, you look at calculation number 2, that will help. And then, the value for the vapor pressure of the water in this experiment is based off of what? What did you use to go down to that last page in the lab and find the number for the partial pressure of the water vapor. What did you use? What is that table? Go back and look at that table, and you'll see, okay, when I look up this, it gives me this number. And then, how was the value for vapor pressure in this experiment found? So what did you have to do to find that number for the vapor pressure of water? Questions? The rest of the hour is yours, ladies and gentlemen. Review sheets are up here. Lab needs to get done and turned in. I don't care if you all get together as one big group and answer these 3-4 questions. I don't care if you do it individually. But it needs to get done and turned in before you leave today, and then the review is here. If you have questions, ladies and gentlemen, raise your hand, call me over, and I will try to help you. I will not give you the answers, but I will try to help you. Go to work.